Now, academic, Monday, April 3rd, 7.1 notes. Okay, so solving these with substitution, okay? Solving with substitution, right? So we get one variable by itself and plug it into the other equation. All right, so for this first one, right, let's get y by itself. So add 9 to both sides. Get y equals 9. All right, that's part of our solution. Then I plug that 9 into here. I get 9 equals x squared. Take the square root of both sides. X equals plus or minus 3. Questions? Comments? All right, B. All right. So we can't get one variable by itself here, right? But we can get y by itself. So, yeah, we can, sorry. So x minus y equals 3, right? We can just add y to both sides, add y to both sides. We get x equals 3 plus y. Subtract 3 from both sides, x minus 3 equals 1. Okay. Plug that in to here. X minus 3 squared equals 3 times x minus 3. Okay, so I'm just expanding it. Negative. These are my two solutions for x. And then to get y, we're going to go back up to this equation here. We'll have to plug in 0. That'll give us y equals -3. So one solution is 0, -3. Yeah, so let's write that a little better. And then when I plug in this x equals -4 to this equation up here, I get y equals -4 minus 3, which is -7. Yeah, I feel like I did that really fast without saying anything, so any questions there? Just somehow indicate that the 0 and -3 go together.
Wait, how do you
What's that?
How do you know that the 0 and -3
They go together, so I got those two solutions for x, right? I only get -3 for y when I plug 0 into this equation. Yeah.
So right here, you get and the x equals 0.
Y equation.
Oh, it's
So it's like algebra 1, but a little more complicated. Yeah, and then similarly, Allie, right? I only get -7 for y when I plug this x equals -4 up here. Does that make any sense?
So how do you know which one to plug in? Why can't I plug in the other?
You could. It would be the same thing. But I just, yeah, it's just easiest. All right. Any questions? He's got a game this week?
Yeah, I think we're going next week to hour, I think.
I gotta go to that one. I'm gonna go to that one.
I think that was
No, I don't want to do
No,
that.
no.
Really?
Yeah.
That's really bad.
They always try to start fights. Like every team is trying to fight.
You guys? Or
Yeah.
Ken?
Well, me specifically. I got elbowed today.
All right, C, the same thing. Same thing, okay? So let's use this top equation. This is now algebra 1 problem. All right, let's get x by itself. X equals 6 plus 3y, okay? And then I'm going to plug that in for x right here.
So that's 6-1.
Yeah, right here, that's how I read it.
Yeah.
All right, I got negative 12 equals 4. Yeah. Yep, so it's no solution. Anyone know how to prove that negative 12 does not equal 4? I don't. It's self-evident. You count. It's self-evident. It's axiomatic. We just assume it to be true. Axiomatic.
What does that mean?
My favorite is the trichotomy property. The trichotomy property, I digress. Trichotomy property of real numbers. The trichotomy property of real numbers. Okay? So let's say you have two numbers x and y. Okay? One of the three following cases must be true. Either x is greater than y, x is equal to y, or x is less than y. One of those three must be true. Does that make sense?
Yeah.
I love that. Hardest class I ever took in college. That's like what we did on the first day. He was like, "This is the trichotomy problem." Because he had to like explain to us like what we could assume to be true. He's like, "You can assume that this is true." Thank you. All right, D. Okay. All right. So we've already got y by itself right here, right? So what you can do is when you have two equations that both have y by itself, you can just set these two sides equal to each other. You can just set both of these equal. So you can just do 1 minus x equals 1 plus 2x minus x squared. Okay? Solve that like a quadratic, okay? So plus x minus 1 minus 1. X equals 0 and x equals 3. Did I do that too fast? So those are our two solutions for x, right? Now let's focus, okay? So when I pick x equals 0 and plug it in here, I get y equals 1 minus 0, which equals 1. But that's only for when I plug in x equals 0. So these two go together. That's going to be one solution. Okay, and then when I pick x equals 3 and plug it in up here, I get y equals negative 2. So y equals negative 2 goes with x equals 3. So those, you can write them like that. If you do a squiggly bracket, or I'll also accept it if you do 0, 1 and 3, negative 2. Yeah, they got to be paired, right? Because if you plug x equals 0 and y equals negative 2 into this system of equations, that won't solve it, okay? So you got to indicate which two to go together. That make sense? Yeah. You can do the other one too, if you like squaring stuff. All right, solve with elimination. All right, hopefully you remember this from Algebra 1. What am I going to multiply this? You guys remember how to do this? Yeah, so for solving with elimination, we're looking at the coefficients. We want to try to get one of the columns to have opposite coefficients, okay? So let's pick x. See the x column, this first column is x variables, second is y. So let's try to get this 2 and then this coefficient to be opposite. What's the opposite of 2? Yeah, so what am I going to multiply this equation by to get there to be a -2 here? -2. So I'm going to multiply both sides of that equation, that whole thing, by -2. So I'm just going to copy down the first line. Second line gives me -2x plus 4y equals 10. Okay. Now what do? Now I add down the columns. Okay, so just add everything down the columns. So 2x plus -2x cancels. Okay, y plus 4y is 5y. 10 plus 10 is 20. So y equals 4. And then once I have y equals 4 to get x, I can just plug it back in into any of these equations up here. So 2x plus 4 equals 10. That's solved by x equals 3. You know how to solve that. Go slow through that one. All right. So there's one solution here. There's one pair of solutions. B, going on to B. Okay, so I'm looking at one of my columns. I can pick the x column or the y column to get opposite. What do you guys want me to do? X, okay. So what can we do? What's the least common multiple of 4 and 12? Or 4 and 3? 12. Yeah. So what do I multiply? Let's make this one on top. We got to make one a positive 12, so let's multiply that by 3. The one on the bottom, then I multiply by what? No, it's not. 3 times -23 is -16. There we go. Now I do what? Add down the columns. 31y. Correct me if I make a miscalculation. What was that? -83. -93. Divide by -31. Yay. And then plug the 3 back in. Either of these. So that's going to be 3x plus 4 times 3, which is 12 equals 6. Am I going too fast or no? I want to go too fast. Perhaps. -2. I'm gonna make mistakes. Everybody makes mistakes. All right, C. Oh, this one. This one. All right. Yeah, we're gonna multiply the top by 2. What? Multiply by 2. So we get 4x minus 2y equals 3, and then copy down the second one. sorry. Sorry. Telling you guys I'm gonna make mistakes today. Very rusty. So you get 0 equals 0. Yeah, so is this always, sometimes, or never true? Always true, right? Always true. So it's all real. Yeah. What's a fancy way of saying this? How do I want to? How do I want to write this? Yeah, it's every. You guys know what the answer is. Try to think of an extra way to write it.
Would we use
If you guys just do.
negative
It actually kind of does matter. I'm not sure what we're doing. Oh, there's no key. So the answer to this, it's not just infinitely many solutions, it's all of R2.
Wait, why is it there?
So if there were one variable we're solving for, it'd be R. Since there's two, you just do R2. Since there's two variables, yep. So what R2 is just a name for the coordinate plane. So this is a picture of R2. This is a picture. It's just all the points. So R2 means every single point in the whole plane. Any ordered pair will solve that equation. Okay. R1 is just a number line. Okay. R3 is like little like you draw it like this. All right. R4 you can't even visualize in your head. Okay. So just write all ordered pairs. That's what this means. Any ordered pair you can come up with. Any real ordered pair. Because there is a distinction between saying infinitely many solutions and R2. Yeah. You can just say all real ordered pairs. I'd accept that. I'm going to go ahead and make that distinction, yeah. You can I'll also take that. All real ordered pairs. Just say all real ordered pairs. All right, solve this guy right here. Solve this guy. So you can't use elimination, right? So you got to use what here? You got to substitute, yeah. So let's solve this guy for y, okay? So divide by x. You get y equals 300 over x. Then plug that in up here. So we have 2x plus 2 times 300 over x equals 100. All right. And then, so we have 2x plus 600 over x equals 100. How do we solve these? Yep, so we want, right, we want all three of these terms to have the same denominator. So this guy, we're gonna multiply by x over x here. Okay, so I multiplied this 2x by x over x. This 100 needs an x in the denominator. Hey, dude. So I'm gonna multiply by x over x. Thank you. Yeah, and then once they all have the same denominator, the denominator goes away. All right. because I just need them to all have the same denominator. Okay, and then put it in standard form. We did really well in this section. What was this, chapter 3, chapter 4? We did well in this last semester. All right. Use the quadratic formula to solve for x. Where's Terry? So I get 100 plus or minus the square root of 5200 all over 4. Perfect square factors of 5200. That is 100 plus or minus, what is that, 20 root 13? 25 plus or minus 5. So there's my solution for x. I might just do that as a decimal. So this is about 43 and 7. Okay. Am I doing this too fast? Okay. So we're good. Okay, and then to get those corresponding solutions, just plug these in for x up here. So this is going to be y, so that's going to be x, and then y equals about 300 over 43. And 300 over 7. Okay, and then again, these two go together. That's one solution. These two go together. Okay. Zoom in. So your two solutions in ordered pairs would be 43, 300 over 43. 7, 300. Just indicate somehow that these are two pairs that go together.
How did you get 5 and 13?
So what I did was I split up this numerator. So I wrote it as 100 over 4 plus or minus 20 over 4. 20 divided by 4 is 5.
So if you simplify it out for u quadratic, would that work?
Yeah. All right. Yeah. So that's it for 7-1. That's literally all she wrote. Yeah, so of the 7-1 homework due tomorrow, right? I'm going to put everything in Schoology this afternoon. Okay. All right. Okay, so let's move on to 7-2. Vocabulary. Are you guys okay if I make this small, the work we just did?
Yeah.
How small can I make it?
You can make it like
really? That's awesome. All right, that whole problem just right there. I don't know why I find that so funny. Okay, vocabulary. A matrix. It's a rectangular arrangement of numbers. That's what the answer key says. That's a good. It's a good working definition, I guess. Could go a little meta. It's very abstract. All the definitions of like numbers get really weird. I'm gonna look this up on Wolfram Math World. Yeah, this is like the encyclopedia of math. So a matrix is a concise and useful way of linear transformations. In particular, every linear transformation can be represented by a matrix, and every matrix corresponds to. In his 1851 paper, Sylvester wrote, "For this purpose you must commence, not with a square, but with an oblong arrangement of terms consisting suppose of m lines and n columns. This will not in itself represent a determinant, but is, as it were, a matrix out of which we may form various systems of determinants by fixing upon a number p and selecting at will p lines and p columns, the squares corresponding of pth order." No. I just like to go meta with this stuff. But in his 1867 treatise on determinants, C.L. Dodgson and Lewis Carroll objected to the use of the term matrix, stating, "I am aware that the word matrix is already in use to express the very meaning for which I use the word block, but surely the former word means rather the mold or form into which algebraical quantities may be introduced than an actual assemblage of such quantities." I don't know, guys. Let's just stick with our definition. What's that? Yeah. Let's just stick with our definition. Okay, rectangular arrangement of numbers. Okay. That's good enough for you guys. That's all we need to know. Okay. So dimensions. The dimensions of like a square, right? That's width and length, same deal. So number of it's rows, right? Number of rows by, that's not a times, that's a by. Let me just write by the number of matrices. Number of columns, sorry, number of columns. So an M by, actually that's, let me do letters that don't look similar. So an A by B matrix, or you'll see it written AXB matrix. That means it has A rows and B columns. Okay, square matrix. This just means same number of rows and columns. Okay. This is so interesting. They actually don't really give a definition on that webpage. All right, and then an entry is just one of the numbers. Okay. A scalar is a real number that's not part of a matrix. Okay. equal matrices. Two matrices are equal to each other if and only if they have the same everything. Same dimensions, and every single entry is the exact same. And every like corresponding row and column. Here we go, transpose. Anyone know what a transpose is? No? So a transpose, to transpose a matrix, you flip. Okay, so the rows, I like to write it this way. The rows become the columns. And the columns become rows.
So you just flip the numbers?
Yeah. Man, oof. It's been a while. Actually, it hasn't been a while.
Can you go up to the scale?
Scalar. Yep. Then the trace of a matrix. So it only exists for square matrices. It only exists for square matrices. That's just the sum of all the entries along the diagonal. Okay. Man. I did a lot of work with matrices for my senior thesis. So, all the memories are coming back. Okay, can I go on? Or are you still writing? I'm going to go on. Okay, so talking about these four matrices. So these are matrices here. Okay, right here, these are matrices. Matrix is singular, matrices plural. Okay, like vertex, vertices. Okay. So A is a what? How many rows does A have? 2. How many columns? So it's a 2 by 2. That's what we call a 2 by 2. What about B? How many rows? 2. How many columns? C is a 3 by 3. D is a 2 by 3. Okay, so A, B, and C are square matrices because they have the same, like the two numbers match. D is not a square matrix because the two numbers do not match. Okay. A plus B, when you're adding two matrices, here's how you do it. So it's going to be written like this. Addition and subtraction are not too bad. And it's just entry-wise. It's entry-wise addition, okay? So the top left number in our sum is going to be the two top left numbers added together. So that's what? 1 plus 6 is 7, okay? The top right number in our sum is just going to be the two top right numbers added together. So that's going to be 1, right? The bottom left numbers is going to be the two bottom left numbers added together. So 3 and then 1. Okay? Any questions, comments, concerns? You guys picking up what I'm laying down? Good stuff. All right. A plus 2b. Okay, so this is still not too bad. I'm just going to copy down A. And I'm going to show you how to do 2B. Oh, crap. Let's make this a little smaller. So I'm going to write 2B here in pink. So to multiply this matrix by a scalar, all you do is you multiply each number in the matrix by this scalar here. So I'm just going to multiply every entry. I'm just going to multiply every entry here by 2. That's 2 times b. So 12, 6, 0, negative 8. Okay? And then I'm just going to add those 2 together.
So 2 be the scalar?
2 is the scalar. It's a scalar, right, because it's not part of the matrix. Okay, and then 2a plus d. So let's do 2a. What's 2a going to be? So how do I multiply this matrix by 2? How do I multiply it? When I multiply a by 2, what does that give me? Okay, good. 2, negative 4, 6, 10. Now I'm going to add d to that. Okay. What do you guys notice? Let me do this in a... They don't match up, right? So to add or subtract 2 matrices, they have to have exact same dimensions. That's for addition and subtraction. It's different for multiplication, but for addition and subtraction, they have to have the exact same. So you can't actually do this. Okay.
So it's just not possible?
Not possible, yeah.
Do we write that solution?
Just write like nah.
Just no.
You're not solving. You're not trying to like solve, technically. I'm just getting more thinking. I don't want to do writing those solutions. Just write nah. Or nah. All right, and then a times b. This is interesting. This is very interesting. I'm the only person I know of that thinks of matrix multiplication this way, but I think it's easier. Yeah, I think I'm going to go for it. Okay, here we go. Here's the best way to think of multiplying 2 matrices together. So it'll be written like this. Okay. So we are doing, first of all, we got to talk a little bit about like requirements. So we're multiplying a 2 by 2 by a 2 by 2, right? So to multiply an m by n, wait, no, I don't want to write that way. So for this to work, for us to be able to multiply these together in the first place, these two outside numbers here have to match. Okay? So the number of rows in A has to be the same as the number of columns in B. Okay?
Is that 2 divide 2?
You don't divide matrices. Yeah. You do what's called multiplying by the inverse.
But you would still need to, like, the same.
Yeah. Yeah. So I write down the dimensions of the first matrix, I write down the dimensions of the second, and I need to check to make sure these outside numbers are the same. Okay? If they're the same, your final answer of, I'll do this in purple. Your final answer, no, I won't do that in purple. Your final answer is going to be a 2 by 2. You just copy them down. So your final answer is going to be a 2 by 2. Okay? All right, your final answer is going to be a 2 by 2. So I'm going to have an orange column in my answer and a green column. Okay? Here's what I think is the easiest way to think of this. Okay? Let me do this on the board. You had like 80 markers. Oh, they're all in the back now. I had like 80 markers. So to get this first column in my answer, to get the first column of my answer, what I do is I take the first column of B of the second matrix, okay? So we're doing 1, 3, -2, 5. And 6, 0, 3, -4, okay? I like to do this, I like to visualize this. To get the first column of my answer, what I'm going to do, I take my two columns here. All right, I'm just going to write them as two columns that are added together. Okay, so I'm going to add the two columns here of this first matrix. Okay, except I'm going to look at the first column of B. So to get the first column of my answer, I look at the first column of B. I'll do it in orange. So I multiply this first column here by 6, that first number on top. I multiply the second one by 0. Okay. This multiplies to 6 over 18. And that adds with, this is just 0 over 0. And that becomes 6 over 18. Okay. And that's the first column in my answer. So that first column right here is going to be 6 over 18. Okay. Then what do you guys think I'm going to do to get the second column of my answer? How do you think I'm going to fill in that second column?
3.
Yeah. So I'm going to add them together again. I'm going to add that 1 and that 3 and that -2 and 5. I'm going to add those together again. But instead of multiplying them by 6 and 0, I'm going to multiply that by 3 and -4. Okay? So 3, 9, and then 8 and -20. Okay, add cross 11 and -11. Okay, so my second column there is going to be 11, -11. That's my answer. Okay. That's how I like to do it. That's different from the way a lot of people think about it. A lot of people do it as like a formula. I like to visualize it. Did you guys follow what I did? Okay. That's how you do it every time. Okay? Sweet. Let's leave off there. Good work today. So 7.1 homework for tomorrow, okay? I'll put it on Schoology.